All right, so this is pre-calculus. If you need to screenshot this, I would highly advise you to do that. It's on your book too, but these are identities. This is where trig comes to play, and it gets a little bit more complicated if you don't know where to start. Here we have all the identities. So we have the basic one, meaning the reciprocal ones, right? Cosecant, secant, and cotangent. It's a reciprocal of 1 over sine, so it's flipped. 1 over cosine and 1 over tangent. But this also comes into play, they don't have this in the book, but cosecant, if I wanted to write it as a reciprocal function, it's sine of theta is equal to 1 over cosecant. So it's a reciprocal of the cosecant as well, and for each of these here. Tangent, theta is equal to sine theta over cosine, and that's something we already know. But cotangent is always the reverse, it's the reciprocal of tangent, so it's cosine over sine. Pythagorean theorems, we're going to use these a lot, especially in the next couple lessons. Here, it's we have sine squared plus cosine squared is equal to 1. We have tangent squared plus 1 is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. These formulas, I would advise you to have it on the side for something, especially when you go in the future and deal with a lot more problems, how to show it and stuff like that. This is where these problems come to play. So now here, example 5, we have express sine in terms of cosine. So they want sine in terms of cosine. So sine is equal to some terms of cosine, but obviously this doesn't make sense. Sine does not equal cosine here. So what we do is we look over here and we see anything with sine and cosine in it. So if I see sine and cosine, let's see what I have here. We have sine and cosine. We look at, right here, sine and cosine. These are all combined. I want it in terms of cosine, so what I can do is I can change one of them and have it in terms by itself. So let me use this identity and show you what I'm saying. I want the sine by itself, just like you're solving for x. Here is I want sine by itself, but I want it in terms of cosine. This is a perfect example because all I have to do to get sine by itself is move the cosine over. When I move the cosine over, and it's a square, so keep in mind that, I have sine squared theta is equal to 1 minus cosine squared theta. So it's sine in terms of cosine. It's equal to something, and that trig function on the other side is a cosine. And that's where you're going to deal with a lot with these other ones. Here, it's not by itself because it's squared, so take the square root of it. You're going to square root both sides. Now you have the sine of theta is equal to the square root of 1 minus cosine squared. And that would be your answer. Your answer would be this function here. It's sine, but it's in terms of cosine. So you're going to be moving a lot of functions around. They also talk about the first quadrant, the second quadrant, third and fourth. That's where this chart's going to help you, just in the corners here. So let's say express sine in terms of cosine in the third quadrant. So sine in the first quadrant, where is it? First quadrant is positive. Sine in the second quadrant is positive as well. But sine in the third quadrant is considered negative. So if it was in the third quadrant, then your answer would be sine theta is equal to negative radical 1 minus cosine squared, because it's in the third quadrant. Here it doesn't say what quadrant, so your answer would just be this right here. B, express tangent in terms of sine. So now we have to see where they talk about tangent and sine, where theta is equal to, where theta is in the second quadrant. Here, now we look at all of this over here, and we have to see where tangent is, where they have tangent and sine together. So up here, they don't really have it except right here. If I look down here, it's tangent and secant, not really. But here I have tangent theta is equal to sine theta minus cosine. So we want tangent on the left side of the equation, and we want it in terms of sine. So the only thing I found from all of these functions is this one right here, tangent is equal to sine and cosine. It has the two things we need, but it has something that we we don't really need at all. We have that cosine there. We need tangent in terms of sine, meaning the other side is going to be in sine terms. Here, it's sine over cosine. We have to go ahead and convert cosine in terms of sine. So here, we got to go ahead and convert it so we can have sine and sine there. If we go back up to here, we know that sine squared theta plus cosine squared is equal to 1. We can go ahead and get cosine in terms of sine, so I can go ahead and plug it back in here. So now, subtract sine to both sides. And then I get the cosine squared is equal to 1 minus sine squared. It's not by itself. You go ahead and square root both sides. So this cancels out. We get cosine squared is equal to square root of 1 minus sine squared. Now we can go ahead and plug it in here. So now we have the tangent of theta is equal to sine, which is what we want. We want everything in terms of sine, over, we know cosine now equals, this cancels out, 1 minus sine squared. And that would be your answer. But now it says in terms of sine, where the degree is in the second quadrant. Now we look over here and we see where cosine, here we're still dealing with cosine here, we're going back there. But now cosine is equal to this equation setting equal to, in terms of sine, cosine in the second quadrant is negative. So your answer here, and I should have done that before, is negative square root of 1 minus sine squared. So now here, this is where the negative comes to play. So now tangent is equal to sine theta over negative square root of 1 minus sine squared theta. And that will be your answer. And that's what I'm going to be asking you for your homework too. There's only going to be a couple problems there, but just take a step at a time. So you have your first trig function set equal to everything in terms of your second trig function there. Number 37, express tangent in terms of cosine. So now we want to go ahead and have it backwards. So now we're going to have it in terms of cosine in the second quadrant. There you go. So I wrote kind of sideways. We know that the trig function we're going to use, something that has sine and our tangent and cosine, is the tangent is equal to sine over cosine. We want it in terms of cosine, so we're going to have to do some extra work. We're going to have to convert this, meaning we're going to use the sine squared plus cosine squared, one of the identities, is equal to 1. We want in terms of cosine, so we're going to try to substitute what sine is. I'm going to move this over. So sine squared is equal to 1 minus cosine squared. Square root it so I can get the squared by itself, because we're just trying to solve for just basic sine. Unless there's a squared there, we would leave it there. But there's no squared, it's just sine. So sine is equal to the square root of 1 minus cosine squared. Before we go ahead and substitute it, here it says the degree is in the second quadrant. So let's see what sine is in the second quadrant. So second quadrant's right here. And sine is positive, so we leave it like that. So in place of sine, we can substitute that equation. So now we have tangent is equal to sine what sine is, which is square root of 1 minus cosine theta over the cosine of theta. Express tangent, that's what you have here. In terms of cosine, everything should be a cosine on the other side of the equal sign. And make sure your negatives and positives are there, and that's where you have this. We have one more, and I forgot to write it down up here. It's expressing it when we have what it equals to. So let's say, let's make room. We have, and this is example 6 now. So example 6, we have if tangent is equal to 2/3, and your Your degree is in quadrant 3. Find cosine. So to do all of that, we have to go ahead and find what cosine is in terms of tangent. So we have to have cosine at one side and have it equal to tangent on the other side. So it's kind of backwards from what we're doing from the example 5. So now, here, we're trying to find something that includes cosine and tangent. So cosine and tangent, there's one of two ways you can work this out. So cosine and tangent is this right here. But we want to get cosine by itself, so we don't really want tangent by itself on one side. But I do know that what we can use is the reciprocal function. Cosine, the reciprocal function is 1 over secant. If I go here, we can use one of these identities. These are a lot easier to use than the ones on top. So we have tangent squared is equal, or is tangent squared plus 1 is equal to secant squared. We know that secant is a reciprocal function of cosine. So we have tangent squared plus 1 is equal to 1 over cosine squared. So we know it's equal to that. Now we can go ahead and solve for it. So here, cosine is not by itself. We can get cosine by itself by moving it. So cosine squared, I can multiply both sides, because if it's in the denominator, you can't really get rid of it. You can't just divide or multiply by 1. That's not possible. Now we have cosine squared times tangent squared plus 1 is equal to 1. We can get the cosine by itself by dividing both sides by tangent squared plus 1. Tangent squared plus 1. Cancel this out. Then you get cosine squared is equal to 1 over tangent squared plus 1. And now, cosine isn't by itself. Here, there's no squared. The reason why we squared it here is because if it's secant squared, the reciprocal will be 1 over cosine squared. But in the end, our answer has to be cosine by itself. You square root it. This cancels out. And then we officially have cosine is equal to, the square root of 1 is just 1. 1 over tangent squared plus 1. If tangent is equal to this, that means we want this on the right side. Then find cosine. Cosine is what we're looking for. We want that on the left side. So now we have cosine is equal to 1 over in this whole thing right here. But now one more thing to check is to see, is to look at the quadrant. According to this, the cosine is considered, or is to be in the third quadrant. If you look over here, the third quadrant, negative is sine, cosine, secant, and cosecant. So cosine is considered negative. So I can set this whole thing equal to negative, or just in the bottom, doesn't matter. Either way, it's still negative. From this step right here, now we go ahead and plug in what tangent is equal to. There is multiple ways of working this out. So it's not just one identity and that's all. Now we have cosine is equal to 1 over the square root of tangent squared. Now we have what tangent is, 2/3 squared plus 1. We had to create an equation to plug it in and substitute it for tangent. Now we go ahead and solve step by step. So I'm going to go ahead and do over here. So I have 1 over, this squared is, I know this is going to be negative. So it's 4 over 9 plus 1. That is equal to 1 over 4 over 9 plus 1. I get 13 over 9, which is then simplified to square root of 13 over 3. And then you have a complex fraction, so you go ahead and multiply by the reciprocal, top and bottom. This cancels out here, it's negative here. Now we go ahead and we have negative 3 over radical 13. Can't have that. The book has it as negative 3 over 13 is your answer. But if you want to keep on going and solving for it, you can, and you'll get 3 radical 13 over whole number 13, and that's what your answer would be. So it's just going step by